Hello everyone, welcome back to the Academy. I'm Dr. Husuli, and today we're gonna learn Polyson software together. Without further ado, let's jump to the software and start to learn it.
Okay, let's continue. Let's open the software, Polyson software. And while we are waiting for the software to load, I would like to give you a brief introduction what we're going to discuss. So we're going to have an introduction about the general structure of the software, then probably the different tabs, manuals, and project management settings. And then we're going to walk through the wizard window and the weather data and the wizard function. We're probably gonna discuss about photovoltaics, inverter layout, yield calculations, batteries, EVs, electric vehicles. We're gonna have a basic simulation and we're gonna take a look at the report, graphics that we can get from the report. We're gonna also discuss about the thermal consumers, domestic hot water simulation, space heating simulation. We could probably add the swimming pool application as well, or process heat maybe for industries. And then again, we're gonna run the simulation in this thermal applications and gonna get the report and probably the graphics and the graphs. At the end, we might be able to cover a little bit about the solar thermal collectors, what we have learned so far during our week. And probably at the end, we're going to have a discussion on the storage tanks as well, as we discussed during our first week. And we're going to finalize and close the session by working out through the assignment and also some practice that you need to do during the class. Okay, as you can see here, once we open the software, we're gonna face two windows basically. So one of them is a wizard window that we're gonna start to work with it right now. And the other one basically is the simulations windows, Polyson simulation window. If you don't have this wizard tab, when you open the software, don't worry because you can click here and then you can activate the wizard function and you're gonna have this window. What I'm gonna do, I'm gonna close this. And as I said, if you don't have this wizard, the wizard window, once you open the software, you can click on wizard here on the left, and it should give you basically the wizard window as well. There you go. So you have it here, and then you can start to work with the software. Okay, what we need to do now, we need to put a name for our project. So as usual, let's put Kingston Uni and then probably number 1. Here you can put comments. So if you're dealing with the multiple simulations, you can put some comments to help yourself and probably maybe your colleagues to deal with the file of your simulation if you're going to share your simulation with them. Then the next part is related to the location selection. Basically, where is your solar system will be placed. You can select from the map either or from the database. So from the map, we're going to discuss this later, but for now, let's go with from the database. Here, you have an option to select different continents, Africa, Europe, South America. We're gonna go with Europe and the country. So we go with the Switzerland and then we can select the locations. So we're gonna select the location that we feel that is gonna be better to place our solar system. So somewhere close to maybe this one, Winterthur in Switzerland. And what we're gonna do, we're gonna click on continue. Here, as you can see, now we move from the project tab to the template tab. And here, as you can see, so we have 3 options to select here. For example, for photovoltaic systems, we could select yes, no, and then an A, which is not applicable. So if we don't select none of these options here, as you can see, we have 1043 templates to select from it. And obviously you can scroll and then you can see basically the outline of the system for different scenarios. So what we usually do, as I discussed for introduction, we're gonna go with the PV system. So if we want to go with any system, basically, all we need to do, we need to select yes. And once you select yes, for example, for photovoltaic systems, you can see that the number of available templates is now reduced to 165. And again, you can navigate through different options and see which one you want to work with. So if you scroll down, you have different options to work with it. Because we're just gonna, for now, simulate only the PV system, we're not gonna have a solar thermal, no boiler, no heat pump, no chiller. And then from the energy provider section, you need to move on to the load or consumer section. So as we know, so because it's a simple PV system, we're gonna select yes for electric consumer, because we have electric consumer as well, but no domestic hot water in this case, no space heating, and then no uh, pool water heating as well. For now, we leave the system size and the other parameters for system specifications as well. Now, we need to select our template, basically. And as we discussed, because it's a very simple for now, we start from the simplest case. It's a very simple photovoltaic case. We're going to select 58 photovoltaic. It's going to take some seconds to load the template for us. What we need to do now, we have different tabs that now added to our wizard window. So we go to the grid, as you can see here, and we have a part related to the grid type. You can click on here, and then you have different electric grids that you can pick. Different options. So for now, we're gonna go with 3-phase 230 volt. You can double click or you can click OK. And then all the field is gonna be completed automatically for you. You're gonna click on continue, and then you need to select your PV module. So here you can define your module type, orientation, tilt angle, and number of modules. Starting from the module type, you click again here, and the software gonna show you a huge library of the available PV modules. What you can do, because as you can see, the list is too long, you can use the filter here to select and find your suitable PV module that you're looking for. What you need to also be cautious about that, you need to select the column that you want to have this keyword. So for example, you can go with the name or the data source or the manufacturer. So we go, for example, with the manufacturer and we select a PV module. So let's type one of the manufacturers, for example, Solar Zentrum. So once you write it, you can see that the number of the available modules is now reduced. You can see different information about the modules here as well. So as you can see here, you have efficiency of the modules, and STC means standard test condition. So efficiency of the standard test condition, and nominal power again per watt. Again, STC means standard test condition. You can select your favorite collector from here, module from here. If you don't have any module here, or if you have let's say you have these lists and you couldn't find your module that you're looking for, what you can do, so you can select basically any module here, and you can create your own module with a specification, its own specification. What you need to do, you have to select one of these, don't double click, just select, and then you go and click on here, copy marked line. And you put a name for it. So we call it, for example, now, let's say put new and then Kingston Uni. We click OK. And as you can see here, now I have a new Kingston Uni with a specific catalog number. And what I can do now, I can click here while selecting my new module. I'm going to select here, change mark line. And as you can see, now I can modify the values, basically overwrite the values. So I can put efficiency of my own specific module. Imagine if you are ordering from some unknown manufacturer, but you know the numbers about, for example, the nominal power, efficiency, etc., etc. So you can do this. You can add this any component to the Polyson library anytime you want. For example, in any other module selections as well, solar thermal or inverter or anything. If you can't find anything, you simply could create it. For now, we're gonna go with the default one. So something we're gonna select from here, and we're gonna go from this part basically. So we select this one with the efficiency of around 13.5%, C220p from Solar Central. I'm gonna double click on that, and it's gonna be here on my module type. Now what I need to do, I need to define the orientation, tilt angle, and also number of modules. So in Polyson, orientation, as you can see on the helping graph here, basically if it's 0, it means south. If it's positive 90, it's east, and any minus value is gonna go from south to west and to the north basically. So minus 90 is west orientation. So imagine if I want to go with the southeast angle, it's gonna be positive 45 degree for the southeast angle. And for this case, I'm go with the 0. I'm gonna select the south direction for my orientation, and then I have a tilt angle. So this is my tilt angle. 0 is gonna be for basically for the roof, so flat roof basically. And if I put 90, is gonna be a facade type collector and module installation. And then I have also the number of modules here as well. So I can put any number I want, but for now I put 0 for the orientation, 45 for the tilt angle, and I'm gonna go with the 10 number of modules. If I click continue, now Polyson is gonna basically suggest me suitable or possible inverters that can match with the PV module that I put, with the grid system that I had. So I need to now select the type of inverter that I need to work with it. In inverter section, what we have basically is a different, as I said, different options that Polyson suggests for us. If you take a look at the types of the inverter, you see number as a percentage, as 109 or 100%. So basically, what is this? It's a power ratio of the inverter, and basically it's this factor is basically between the nominal power of the module field, basically all of the solar PVs that we have, to the DC input of the inverter. So as you can see, if it's 100%, it means that these two values are matching with each other. And if it's more than 100%, it basically means this over-dimensioned. And if it's below this value, like 75%, 89%, it means that it's under-dimensioned, this inverter, to match with our PV layout. As you remember, if I go back to PV generator field and the PV that we have picked, basically, let me check here. Yes, here. As you can see, and if you remember, I discussed about the STC, so standard test condition, which means that if the nominal power of our PV module, any number, is basically based on the standard test condition. And in the real world, it's very difficult to reach the condition of a test condition. So it would be okay if we select a little bit under-dimensioned values like 89%, 75%. But obviously, because it was based on the standard test condition, selecting a value higher than the 100%, like 109%, is not really okay because it's going to be over-dimensioned too far. So for now, we're gonna go with this 100%, which matched basically perfectly with our system as Polyson suggests. And then we select this one, which is basically the 100% matching inverter, and then we click continue. For the other parts, for the other parts in terms of the cable losses and etc., we leave it as it is. Then continue, and this window is really important, which is called PV validation. So as you can see here, based on our selections and the suggestions from the Polyson, as you can see, all of them are green, which means that the different components are matching with each other. It's not only considering, for example, the values that we have discussed in our inventor, as here, for example, the 100% about the power ratio of the inverter, but also it's already considered other values like the maximum system voltage to be matched or maximum input voltage, and all of the values basically is now matching, and all of them are green. If we find something in red, what we need to do, we need to come back and revise our system. Now we select and continue, and we're gonna go to the most important part basically, which is the electric consumers. In electric consumer tab, we can select the number of electricity consumption profile. So if I select one, I'm just gonna have a consumption profile, just one consumption profile. But if I have, for example, multi-family houses, or for example, let's select two, and if I have two different profile of consumption, then I have this option to select them differently. For now, what we're gonna do, we're gonna go with one, and it's important because we're not just only focusing on total annual consumption per kilowatt hour here as it's stated. If I click here, as you can see in this tab, which is the catalog of consumption catalog, basically in Polyson, you could see different profiles, which means that how the consumers are basically doing the electric energy consumption. What else I would like you guys to be aware of is, let me expand this tab here. So I have a load profile of H01 for a couple, both age under 30 and both are working. So this is one profile, as you can see here. But you might also notice number 45, which says 15 minutes load profile, H01, couple, age under 30, both working. These two looks very similar. However, pay attention to this 15 minutes. So it means that this data sets is more accurate. It's been accumulated every 15 minutes, but this one is every 1 hour. If I go to the right and then expand this tab a little bit more, maybe, you see that these old profiles are based on the CSV type file, which is basically an Excel file. And as you can see here, it shows you also the directory for this tab. So if I open this directory in my Windows Explorer, basically, and then go to the Polyson and then to the profiles, you see that I have all of these profiles here in this folder. What I would like to also show here is that, as you remember, we have one H01 couple under 30. If I open this one on my Excel, you see I have let's say around 8,762 data sets. And if I go to H01, and then this time 15 minutes load profile. If I open this one, it's going to take some time. So this is the 15-minute profile. And as you can see here, now I have around 35,000 of data sets, which means that this is more accurate and it's been recorded basically every 15 minutes. Let's go back to our Polyson. And this is the catalog basically. You can select anyone that you want. We can go for this example with the simple residential profile. But as you remember, in all the catalogs in the Polyson, we can modify them or we can add a new one. So if I want to add a new profile, imagine if I have a CSV file of a specific profile for a specific family, I can again copy mark line and then call, for example, Kingston Uni load profile. I would click OK. Now, as you can see, I have a new catalog number and the name. And as previously mentioned, I can go and select the change mark line. And here, what I can do, I can double click on this section here. And it's going to ask me basically to select my Excel file, the CSV file. So I can then select it and then find basically my specific load profile, a custom load profile, open it, and it's going to be loaded for my case. So if I have a custom load profile, I can go through this function. For now, we're going to go with the simple residential profile. We're going to select OK, just one profile, and accept. So once you accept this, what you're gonna notice here is that Polysun start to do the simulation for you. So as you can see here, it's downloading the data from the metronome, and it's gonna take some while to do the simulation for you. As you can see, now it's completely green, and it means that the simulation have now been completed. Now we have our result overview, as you can see here. We're not gonna go to the details now, the results basically now. We're gonna close this result overview now. So now what you have here is basically the graphical representation of your system. And this is something really good about the Polyson that can provide you this graphical representation. Another good thing is that now you have availability to modify basically these graphical representation. So for example, if I double click here on my photovoltaics module, then I can again do some modification if it's needed in terms of, so for example, changing the module type. So I can double click here as well, and I can rearrange or change the type of the modules that I have. What else I can do here? Again, it applies to all of them. So if I need, for example, to change the electric heat consumption profiles, I can here change it, the type of the profile, etc., etc. And it's also important to mention that, for example, I can add new components here as well. So I can add a battery, for example, here. Obviously, we need to define the battery specifications in details as well. But for now, just remove this by pushing delete on my keyboard. What else I can do here is that on the left-hand side under the project, I can right-click on this and then I select basically copy system diagram. And what it's gonna do basically is gonna ask for a name. I'm gonna call it number 2, for example, and click OK. Now I have, this is really good in order to make a comparison between two different systems in terms of simulation. So I can, for example, for the first one, I don't have the battery. For the second one, I can, for example, select different type of the PV panels if it's needed. For example, PV modules. I can go, for example, with this one, click OK, click OK. And as you can see now on the first one and the second one, I have different types of the PV modules. What else I can do? I can also copy and select again, call it number 3. OK. And for example, I can add a new component here as a battery as well as I mentioned. Another way, so once I'm running the simulation, is basically gonna run the simulation for all these 3 systems, which gonna be helpful for me to make a comparison. What else I can do here? As you can see here, I have a template tab here as well, which basically I can add different variants to the system. So if I go to the standard templates, for example, here, and then I can go, for example, to domestic hot water system maybe, and then I can select maybe this one, hot water solar thermal. As you can see, if I double click here, it's going to ask me if I want to add this template to my project. I would say yes. It's going to ask for a name. I would say yes. Okay. And now I have it here as well, as you can see. So I have now 4 systems. 3 of them is photovoltaic. This one is hot water with flat collector. Another thing, for example, I could do here is, in this case, for example, I can modify also the connections in my system or add the new connections as well. So for example, as you know, this is a 3-way valve. I can select that one, push delete on my keyboard. It's gonna delete that one. And this is the controller. I can delete the controller as well. What else? I can delete this one as well. I can delete this one as well. And then I can basically connect these 2 together. Sorry. Delete this one. I can connect these 2 together and also these 2 together. So now I have the system, but without 3-way valve. I can also, as I said, add new components as well. So what I need to do, again, maybe I can remove here, I can remove that one. From the left-hand side, for example, I can add again a 3-way valve, as you can see here. Obviously, I need a 3-way junction as well. So now what I can do, I can make this 3-way valve again from the beginning. So not as beautiful as it was before, but this is just to demonstrate to you that you can modify the systems as you wish based on your preference. We have also, as you can see here in the template tab, we have also different tabs as well. One of them could be, for example, the companies. So if you double click on that, you have different companies and their products. So for example, one of them, which is also in Switzerland and also they're based in Italy, is, for example, TVP Solar. You can look at their system as well here in terms of you can double click here and it could you could add it to your project similar to the previous ones as well here. You can also delete that one by pressing delete on your keyboard and then click yes. What else you have also in the project tab here, as you can see, I can go to the project overview and here I can load a photo of my property. So you can put it, so you can load a photo here and it's going to appear in your final PDF report as well. You can also go and navigate to the location of the system tab. And this is basically what you have already defined in the Wizard tab at the beginning of the simulation. What else you could do? As you remember, in the Wizard tab, we also had the database and the map. So for example, here I can click on from the map, and then I can open the map here. So it's gonna show me the map, and I can, this is the location I've selected. If I, for example, zoom in, as you can see, I have these red orange triangles, which basically these are the mountains peak. These are especially important when you are designing a solar field in the area that it has a mountain, because it's gonna have basically affect the natural shading, for example. So for example, here you see lots of basically mountain peaks. I just select somewhere around here, for example, then click OK. And now, as you can see, now the new location loaded to my simulation. And there's difference between this figure here when you are doing the edit in the project tab and when you are doing in the wizard section. As in here, you don't see the natural horizon. If you do it through the wizard at the beginning of the simulation, you already can see the natural horizon. But in order to see it in the horizon figure here, I click edit, and now here I have all the information, and then I can read the horizon basically from the file or usually from the metronome. So for this case, I'm gonna load the horizon or read the horizon from metronome. It's gonna take a couple of seconds basically. Now, as you can see, now I have an added basically part to my horizon line. This graph is also really interesting because if you can see on the sun path section, I can basically see the sun path during the entire year basically. So in winter, starting from 1st of January, as you can see, I have a shorter day, so therefore I have a shorter sun path as well. While we're going through the summer, as you can see, now I have a longer days and basically longer solar path. And usually from end of June, 21st of June, then you can see that the days are now shorter, and therefore the sun path is also shorter as well. You have this information, and you can do this for every location across the world. So you have this data from metronome, and this is basically in confirmation to what we have already discussed during our class in the first week as well. I'm going to click OK here, just to show you again that this could change. I can open the map again, zoom in a little bit, and maybe I change my location to here. And then if I click OK, confirm the location, again, as you can see, I don't have it. I click edit, then read the horizon from metronome. It's gonna load it for me, take a couple of seconds, hopefully. And then I should have basically the horizon line in my graph as well, as you can see. Again, I can see the sun path throughout the year for this specific location. I see that it's a little bit different. So I'm gonna come back to the previous location as well. For example, somewhere around here. And this is something good about the Polyson, that you can modify your information every single time. Then again, edit, and I should have all the information again for my location. Another good thing about this horizon is that if I click edit again, I have obstruction sections here, which means that I can add manual obstacles to in front of my solar field, for example. So we can consider different conditions here, but as you can see, this image could help you as well in order to define it. But let's put that, so as you can see, these are D's and these are H. So I can put, for example, I have a tower with a distance of 10 meters with the height of, let's put 8, and about the angle. So as you can see here, this might help you as well. So east, it's going from 0 to 180, and the west side goes from basically 0 to minus 180. So here, what I could do, I could put, for example, 90, and for the second angle, I'll put 85. So now if I add this obstacle to my horizon, take a look at. So I have now a manual shading on an abstract in the path of my sun. So for example, let's change the day somewhere around end of April. So as you can see now, if I change the hours, so I have some shading during the morning because of natural horizon and natural basically mountain peaks that I have in my location. And then while I'm going, as you can see here, for example, here it's like 5:28, and then I have a sun over here, and then during the sun period of the morning, between 7 until 7:30, for example, more or less, I have a shading because of my buildings, basically. So then the sun pass goes, and then we have a sunset as well. So it's interesting because if I change also the day, this period of time that I have this shading because of the buildings now changing, as you can see. So this is a very handy tool which you can use in your simulation. One other important thing here is that if I close this, it's related to the weather data. As you can see here, now we are at the web service version, which basically is metronome 8. If you don't have access to the internet, then you have also other alternatives here, as you can see. So I can go with the metronome 6, for example, based on the library that I have. So here, because it's an educational license, so just I have access to the metronome 6, which basically less updated version of the metronome that you get during the web service, but it can also help you during the simulation. What is also important here to mention is that so metronome 8 is basically based on more current climate period, and usually metronome is about like an average of like 20 years. So standard period for each metronome usually it's like for 20 years. So for now, because we have access to the internet, we go with the web service. But in case that you don't have access to the internet, you usually can use this options here, depending on the license that you have. As you can see here as well, that we have also downloaded all the metronome versions that we were looking and discussing about. Okay, now what we are going to do, we're going to set the location based on the database and the web service for now. And as I mentioned before, we can navigate through the different menus here, as well as, for example, the project overview or different systems that we put. Also, you have different tabs and menus here as well on the top corner. So you can start from the project, you can save or open your projects, Polyson projects. Then you have the system diagram, which basically is the same as what we have here. So usually we work with what we have in the project section, project system diagrams here. And then we have results, which we're going to cover this section shortly. We have catalog, which basically is the library of the different components that we have in Polyson, storage tank, PVT collectors, photovoltaic thermal, or for example, even further catalog, you can go and you have different components as well here. The next menu is option, which if you go to the setting here, which I would like to show you, you have ability to change the units. So currently it's in SI, meter, kilos, for example, kilowatt hour, kilowatt. You can change it to the megajoule, or if you want, you can work with the USA units as well. For now, we leave it as SI. And then you have the currency. So if you want to do the economic analysis, profitability, then you go in currency, and then you can change depending on your case. So we can put, for example, on the British pounds for the moment. Then if you go to the report, you can have your company logo. You can write your name as you are creating it and all the information that you want to put in your report as well. Then you can click OK, and it will be saved for you. You have also the help. You can click on the user manual, and usually it has it shows you basically the PDF file of the user manual of the software, which it has a very long 299 pages user manual, but you can use it because it's very helpful. And if you are dealing with any problem anywhere, you can come back to this and find possibly the answer to your question or problem. Let's move on to the results section as we promised. So we have different system diagrams, as you can see here. We're going to start with the first one, the simple photovoltaic system that we have defined. We're going to go to the result tab. The first one that we have is the result overview. In the result overview, this is, as probably you remember, this is the first window that we saw when we run the system at the first time, which give us some information, but all the information that it gives us is a very rough information. So it's very difficult to judge the system based on the result overview. So what I would suggest to always go to the result tab and then use the system results. So as you can see, this system results gives us a more detailed information in terms of our production and also in terms of our consumption side in our designed system. So it has also the graph, so you can see different graphs as well. What we need to do now, start to maybe to look from the production side. One of the most important factors here is the radiation onto the module area. So basically shows us radiation onto the module area, tilt and oriented basically. So this is not the weather data. So if you want to look for the weather data, we're gonna go through the component results, which we cover shortly. But for now, remember that this is only the radiation onto the module area, and basically, which is important for us in terms of the PV production. The next one is yield photovoltaic DC. As you can see, we have 2,515 here. And then we have yield photovoltaics AC. And as you can see, the total number per year is slightly lower than the DC one. And this is because of the inverter that we have. So what we are usually deal with is this one, the yield photovoltaic AC. This is all about our production side. And as you can see here, you can also look at the values. So here I have, for example, starting from January to December, and obviously during the summer months, I have higher production for the photovoltaics, 256 kilowatt hour, in comparison to the December, which I get only 78. Same values, you can see them also here. So 78, 102, and the total value of 2,200. It's same for all the other factors, and these are our important factors in our production side. And then next move to the consumption side. In consumption side, we deal with the different parameters as well. So might be interesting to start with the total electricity consumption. And as you can see, the yearly value is 3,500. And as you can remember, we defined this value when we were defining our system. So if I close this and come back to our consumption side, you remember that we put 3,500 at the beginning with the residential profile for it. Obviously, if we change this value, the results will be changed as well. So if I go back to the system results, the total value is 3,500, as I mentioned. And if you look at the distribution over the months in a year, you see different values, which comes from the profile that we have. So if we change the profile, the total value is going to remain the same, but all profile values or values monthly will be changed because of the different usage profile that we define for the system. We discussed about the yield photovoltaic AC, which is our total production of our system. And it's also worth to mention that we usually produce in the PV system in the time that even we don't need the energy. So if you don't have a battery, usually the production values are could be higher or lower than what you actually need. So basically you produce in a time of the year or months or hour of the day that you don't need the electricity, but you have the production. So this is basically shows your total production. And this is the self-consumption. So how much of these total production you use? So we do generate energy, as I said, when we don't even need it. So we can't consume it even. So this helps us to define the self-consumption. So these are the self-consumption. So in the January, it's 68 out of 111. And if we divide this self-consumption value to the total production, it gives us self-consumption fraction. So as a total, it's 55%. And then, as you can see, 61%, and then 51%, because obviously in summer months, we have a more excess production than what we are producing. Remember the difference between the time of the production. So you might need electricity at night that you don't have a PV production, and you don't have a battery as well. Remember that we didn't have a battery in our defined system. Which helps us actually here as well. So if you look at the direct consumption and self-consumption values, you see that in this case, these two values are identical because exactly the same, because we don't have electricity. So everything that we produce, we need to use it. So we don't have a battery. If we have a battery, the direct consumption and self-consumption value will be different because we can store from those electricity that we're producing and we don't need in that specific period of time. So what we were doing so far was focused on the self-consumption comparison with our production. The other way to do the system analysis, to do the comparison between the self-consumption values and your total electricity consumption. So if I divide the self-consumption value by the total electricity consumption, it gives me the degree of self-sufficiency. So it's 35% annual value, average annual value, and then you have different values over the months of the year. It's also important to mention here, because as I said, we don't have a battery. So we have this total production. Let's consider the January value, 111.3. If I use self-consumption value of the 68 out of this, so what happens to the rest? So because we don't have a system, so it goes to the external grid. So these two values are complement each other and it's equal to the total production value that we have. So 68 plus 43.4 is equal to the yield production or total production from our PVs. For the period of time that, for example, that we don't have a PV production, then where we get the electricity for our system is from the external grid that we have also here. So as you can see, we have 358 for that specific month. We have some production as well. However, this is not enough to cover. So we have 111 from our PV production. However, I need 358. So the rest is gonna come from our external grid covered. So as you can see, 291 coming from external grid. these are the main and important factors that we need to discuss here in the system results. And now we're gonna go to the component results, trying to discuss more in details or system. In case that you need more detailed result, you can go to the results section and then component results. And as you can see here, then now you have all the detailed information about the system. So for example, as we discussed, you have access to the weather data, such as, for example, average outdoor temperature, uh, normal direct radiation, and etc., or even you have for your consumption side detailed information as well. What else we could do in Polysun? We could do comparison between our systems. So do you remember that we have copied our current system? Now I have this system without battery, and then I have the other system with the exact same PV modules, 10 PV modules, same type, C220P as this system. The only difference here is in our battery. So the consumption side is actually the same. Everything is the same. Inverter, all the system components are the same. But the only change and difference is the battery that we put here. So if I want to do a comparison between these two systems or even more, I can go to the results and then system comparison. So here I can pick the system that I would like to do a comparison with. So as you remember, we have our photovoltaic system, and the photovoltaic system 3 is the one with the PV with the battery. If I click OK, it's gonna run the simulation. Now I have comparison of these two results. It's interesting to see that the yield photovoltaic, the production from our PV modules is the same between these two systems. And the reason is that obviously we didn't change our PV module. So same module, same number of the modules. So it's obvious that the production is the same. But if we go to the self-consumption, now it becomes interesting. And as you can see here, with the yellow one, with the battery, as you can see, we have now higher self-consumption because obviously we can save the production from the PV modules and use them later, especially during the summer that we have higher production. These values are not that much different in the winter because we don't have that much production during the winter months. If I go to the external grid, this is even more interesting because now we have less excess amount because if we have excess amount, we can put it into our battery and store it and use it later. So we have less values to the external grid, especially during the winter. And from external grid, it's also interesting because it shows that these values are not that much different, and you might brings this idea that how we can optimize our system. Because as you can see, during the winter months when we don't have too much production, these two values are very close to each other. So we have a higher amount of need for the electricity, but we don't get from either of these systems. During the summer months, as you can see, because it's a slightly small system with just only 10 PV modules, so it's obvious that even during the summer months, when we have a higher production because of the higher sun, but again, we do have some needs from external grid to cover our consumption needs. However, these values are lower for the system with the battery during the summer in comparison to the system without the battery. So this could help us a lot in terms of optimizing our system and finding where we can and how we can improve our system. Okay, if I want to do more in detail analysis about one of my systems, it could be this one or it could be the other one. So let's start with the one with the battery. So if I want to do more in details analysis, I can go to the results tab and then go to graphical evaluation. If I click on that, in this window, I can basically discuss about my system in detail. So if I want to pick one of the bricks, so let's pick this one, which is basically April and May. So from end of April to first week of May. Then what else I could do? I could click on add curve and add the curves that I would like and I'm interested to do uh, analysis on them. So let's start from the PVs, photovoltaics, and the most important one is the energy production from more photovoltaic. I double click on that, and as you can see, while I'm double click on that, it's added to my table, and also I can see the curves here as well. Then the next that I'm interested probably is our uh, electrical consumers, and then I go to the direct consumption. I double click on that. Now I have it here as well. The next one that I'm interested, probably I would like to know how much I charge and discharge the battery. So I would add battery charge, and I would also add battery discharge here to my graph. And last but not least, I would go and see about how I'm dealing with the grid. So I'm going to the electrical grid, to the external grid, and from external grid. And then I click OK. Now, as you can see here, the scale of the graph is not ideal. So what I can do, I can optimize horizontal scaling, and I'll also optimize the vertical scaling. I do feel that the horizontal scaling is okay. I can just modify or optimize the vertical scaling. Now, it seems okay to me. However, it's very difficult to distinguish between these lines. So what I could do, I could modify the lines or colors of each of these uh, parameters. So what we can do here, I can change the color. I put this as black. Now you see it changes. And then I would electric consumers, I would put as maybe light green. And then I would put as battery charge as blue. I would put also battery discharge as blue because it's a dot line, so it's not gonna change the effect, basically, my system. Then I would pick red maybe for this one, and also red again for this one, which is a dotted line. So now this is a really interesting graph, which can help us to understand maybe better our system. So if you take a look at this one on the right hand side, you see that I have higher energy production from my PV panel, so it's on the highest amount. So what happens when I have high production? So as you can see here, I have a battery. So the battery now is charging. But what happened is that because the capacity of my battery is small, so what happens? I have a sudden drop down, but on the other hand, I have high value which goes to the external grid, which is red line. So it means that I have a higher production. I charge my battery. Once it's fully charged, because of the capacity of battery, the excess production is gonna go to the grid. If I look at my consumption profile, is also aligned with what's happening here. So as you can see, once I don't have any production from the PV, probably after the sunset, as you can see, it's 1 o'clock and then it's 7 p.m. Now what I need the most is gonna be the discharge from battery, as you can see here, this dotted blue line, which I'm getting basically the energy from the stored in my battery during the whole production period. However, if I look for the other days, and also during the night, as you can see, if I shift a little bit the graph to the right. So as you can see here, after I use all the stored energy. So yeah, as we similar graph, as we used all of our stored energy in the battery, as you can see here with this dotted line, yeah. Then what happens is that once I discharge completely my battery, then I'm going to have this dotted red line, which means that I'm getting the energy from the grid. So this is for a high production day, a day that I have a higher solar input, and then I have higher energy production from my PV panels. However, in a different days, for example, like this, that I don't have that much production from my photovoltaic modules, as you can see, the consumption is almost the same. However, in this case, I try to charge my battery. So I charge a little bit my battery, but I don't have that this red line, which means that I don't have uh, enough excess electricity production from the PV modules to put it to the grid. On the other hand, I have a higher, so smaller period of time that I can use from this dotted blue line from the battery, but on the other hand, I have a higher values of the electricity that I need from the grid. So this graph could help you a lot in terms of identifying your system in terms of how it works. You can navigate through the different days or periods of the weeks, for example, by these two bottom. You can shift to the curve to the left or shift the curve to the right. What else I could do? I could again go to graphical evaluation. Similar to the previous one, pick a week and then add a curve. For now, let's put, for example, again, go to the photovoltaics. I put, where is it? Energy production, AC, energy production AC. And what else I need to add? For example, I can add, go to the consumption side. I add total electricity consumption, and also I add direct consumption here as well. Click OK. As I said, I'm gonna optimize my vertical scaling. It's good to mention that, for example, if I put black for this one similar to the previous one, my energy production, what I need to do now, I'm gonna change the color to yellow here, and this one probably to red. So you can see here that's very interesting that my direct consumption follows in some parts the pattern of total consumption. So if the red one is a total, it follows this route. And a part of the day that I have PV production, my direct consumption from the PVs is follows that. And the rest of the day, when I have still some consumption needs, what I don't have PV production, then my direct consumption becomes zero. For this graph or for any other graph, what I can do, I can also save the graph, make a screenshot of the graph as SVG file or as a PNG file as well, and it's going to save all the information for me. So let's close this window here, graphical evaluation. If I go back to the results, the other one that I have is results in the form of the table, which I can use it basically to put the values in the Excel file and then do the graphing, or in a MATLAB or any other software I can use here. If I go back to the results, I have also a professional report, which you need to also put in your assignment as well. So if I click on the professional report and then PDF document and click OK, Polyson automatically is going to generate a PDF file for me, which includes the most important results for me. So it's also important to mention that don't use this PDF file as a final uh, to do a final analysis. Just use it to present your results, maybe for a client in the future as well. So you have most of the important informations here in terms of the yield photovoltaics. So as you can see, for example, I don't have anything here. So what I can do, I can close this, go to the option and go to the settings, and here the report, and I can put my name here. So OK, and then I click OK. If I go back to the results, and if I go back to the selecting the system that I would like to have results on that, and then go back to the results, professional report, PDF document, click OK, and wait a couple of seconds. Now I have my professional report with all the information of my system. Then now, as you can see, we have all the information for who created the, the report. What we have done so far was basically focused on the information we got from the wizard section here. Considering a case that we might impose by our partner or imposed by a user that I need a specific kind of inverter, because as you remember, the wizard automatically select the inverter for us in our system. So let's go to this photovoltaics 2, and uh, as I said, let's consider that a consumer imposes us to use a specific kind of inverter. So if I click here on my photovoltaic section, as you can see, inverter layout is now set up at the wizard, which means that wizard function set up the wizard for set up the inverter for us automatically. If I double click on that and go to the manual, now I can select my inverter manually, as you can see here. So if I double click on that, now the inverter catalog will be open, and then I can pick my inverter. So you can select any kind of inverter that you have probably. So I go with, for example, I'm just picking blindly here. So it doesn't mean anything, or it's not properly selected for the system. So I might go with, for example, uh, this one or any other one. You can select any other types as I want. What is important to also remember here is usually for us, the maximum power DC is the value that I'm looking for in the inverters. For this one, I just select this one randomly. Now I have an inverter, and then I click OK. What I need to do now, so if I click OK, now I have this one, my photovoltaic. I need to click wizard here as well, again, not here, remember, on the photovoltaic window. If I click here, now similar to what we have done at the beginning, will happen. A wizard window will pop up, as you can see here. But it's good to notice that now, because it's a manual inverter selection, I don't have these two. So if I click continue, I don't have any change in the PV modules. It's gonna jump over these two, PV design and PV, these two tabs, and then go to the PV validation section now. You remember that it was all green, but now, as you can see, I have the first problem is that the power ratio is now 480%, but this is not the main problem, even if it's way over what we need. But this is the problem here I have. So the minimum MPP voltage now is 252, but the limit is 290. So this is a problem for me. So this is a reason to tell us to don't go manually in the inverter unless it's imposed by your consumer or by a company partner that you need to use a specific kind of inverter. So this is a problem and we need to solve it. So what we need to do now, we need to select a different kind of inverter. So I close this. I go back to let me close this one as well to just show you again. So if I want to modify this, I double click on the photovoltaic section and then I go to the inverter. What else I would like to also mention is that, so if you look at the catalog of inverters, which is very important as well. So as you can see, we have also the number of MPP trackers, which means that, for example, in the previous case, it was 1, but now in this one it's 2. So if I pick, for example, other one, let's pick this one, 12. And if I look at to number of MPP trackers, which means that now I have 2 sets of springs basically. So which means if I click OK on that, double click on that, as you can see, now I have layout 1. So number of inverter 1, which is true. However, now have A and B. So which means that previously for the orientations, for the tilt angle, for the number of the modules, I had just need to select from here, the total one. But now what I need to do, I need to put everything for these 2 separate strings. So I have this one inverter, number of strings 1, number of module per strings. So I put 5. I have 5 on string A and I have 5 in strings B. Let's put also, for example, orientation here. Let's put as a 90, 45. Yeah. And in module here, I put minus 90 and sorry, this is module per spring. So it's 0. This one is number of string 1 and module per string 5. That's true. So orientation, I put minus 90 for this one and then 45. Now, which means that I have in total 10, 5 in string A and 5 in string B, with the one inverter. So this system, it has just one inverter, 10 total PV modules, which separated in 2 strings, 5 in A and 5 in B. I have also I have also availability, for example, to put to select different types of to different types of systems here as well. So what I'm gonna do, I'm gonna look for a photovoltaic system, grid connected, as I remember. So this was our first system, modules and one inverter. But I can have, for example, 2 separate fields with 2 separate inverters as well, or 3 separate fields with 3 separate inverters. So what I've done here previously, basically I have not this one, it was this one, I guess. Yeah, what I've done basically, I've changed the inverter in a form that we had the now one inverter, but separated in 2 strings with 5 modules on each string. I would like to also cover other photovoltaic systems as well here, as we discussed at the beginning. So one of the important part nowadays is electric vehicle charged by photovoltaic energy. So what I see cars sometimes, I see cars as a storage with wheels. So batteries with wheels. So I have this one, which only can charge charge car through the only PV, but 50T can charge the car with electricity from the PV modules and also from the grid. So I select this 50T and I add it to my projects. Here, as you can see, if I double click on my car, it's very similar to the other profiles that we had. So I can select my electric vehicle here. So I have a range of cars that I can select as a car that the family that I'm designing the system for them has, from the different Tesla Model S or other electric cars. Or even if you know the specification of your own car, you can simply add it through the similar way that we to the catalog that we did, for example, for the consumers, for the PV modules, etc., etc. Then you have the charging station. So you have again a catalog of different types of charging stations, Tesla supercharger, for example, or other chargers basically. Again, you can add your own as well here. And that Finally, you have the mobility profile. So if you double click here, it basically shows the different profile that the family uses the car. So 2 days per week, or for example, for weekly profile of electric vehicles, and then you can also modify them as well. The good thing about this mobility profile is that, as you can see, it's a CSV file as well, similar to the load profile, but you can also do editing here as well. If you click on this edit icon over here, you have this window which basically shows days of the week and then hours. So the blue basically means that the car is in the road and means that 10 kilometer at 8 o'clock until from 8 to 9, and then 10 kilometers from 12 to 13, and the others it's at charging, which means that it has the possibility to be charged, but obviously it depends on your PV system as well. What you can do also, you can select, for example, let's say I would like to have my car at my place. I'm not going to driving during the weekend. I can select by holding the left key on the mouse and then click edit, and then I change it probably to a charging station, and then click OK, and now it's going to be charged. Even what I can do, I can also select again, edit, and then undar, and it's going to be undirectly charged over here. Then I can click OK. Polysun is going to ask me that if I want to do the overwrite or do I want to create a new user profile? I click yes, I want to create a new user profile, and then I call this profile to Mobility Kingston University. And then I click OK. Now I have a new profile. I can select that profile and then click OK. Now I have this custom profile as a mobility profile for my PV car, and then I can run the simulation for that one as well. Okay, I believe that this should be enough for the PV systems.